Good afternoon, period 6. And, well, I want to post another homework page for you guys in the guided notes so that you can continue in your learning. So far, we've done the first 2 pages. I've posted them online for you guys to copy. And now we're on the 2 homework pages. Now, I'm most likely only going to do 1 page of this homework today, and then hopefully this second page by Friday. The second page a little bit more in depth. We'll probably only do number 6, and we'll just disregard number 7 for now. I like number 6. It actually has that visual representation of the graph. And it talks about what we've been discussing over the last couple pages of notes. But page 1 is very useful. It would be super beneficial if you had a calculator to do this page. But if you don't, it's not necessary. I'll try to work you through it algebraically. So we look at question 1. And question 1 asks us, which of the following could be the equation of a quadratic shown below? Explain your reasoning. Now, there's a couple things I realized right away. 1, there's a maximum. And it's located right there at the highest point of the graph. Now, I know that the equation for a maximum has a negative a squared term, right? And it's y equals. So if I know that the a term of my quadratic is negative, I can totally disregard choice 2 and 4. Choice 1 and 3 obviously will give me graphs with maximums. Now, the other piece of the graph that catches my eye that I can make reference of, is where it crosses the y-axis. Now, when it crosses the y-axis, I know that the value of x is equal to 0. And I know that I can substitute the value of 0 into my equations and find out what the y value is. Now, granted, I'll just substitute it in for choice 3 to show you that substituting a 0 in for x actually cancels out the first 2 terms and leaves you with your c term as your value of y. Meaning that that point, 0, 11, is on my graph. Now, with that being said, that point 0, 11 happens to be right there at my y-intercept. And if I was to substitute a 0 in for choice 1, my y-intercept would be 0, negative 5. And on this graph, there is no y-intercept at 0, negative 5. Now, moving on to my next problem. Choice 3 was our answer for that question. But moving on to my next problem, I clearly have a question with a table. And it's asking me, based on the quadratic function shown in the table, which of the following is the range of the function. Now, I'm hoping that from our last few pages of notes that we know that range represents the y values of the function. So I'm going to just focus in on my y values. Now I see that it looks like I'm going all the way up to a maximum of 11, and then it looks like it's descending on both sides of that maximum. Now, how do we write that in inequality form? Well, I know that all values of 11 will be a part of my range, and all values that are less than 11 will be in my range. Therefore, all output values or range values, my y values, must be less than or equal to 11. There's my inequality statement. Happens to be choice number 4. Now, moving on to question 3. I actually used the online program for this one, and it's called Desmos. Some of you might be familiar with it. It is a really good tool for just using a graphing calculator in a simple way. And I'll read the question first, then I'll go to the web page. It says, which of the following quadratics will have a maximum value at x equals 3? Now that really tells me that I need a graph that kind of looks a little something like this, where my axis of symmetry falls on that vertical line of x equals 3. Now granted, I know that I have a maximum when graphs, again, referring to question 1, when the graph of the quadratic has a negative a term, meaning choice 3 or choice 4. Choice 3 or choice 2. Choice 1 and choice 4 will have minimums. So now I've narrowed it down to 2. Now, I'm going to flip over to Desmos. I've already entered my equations in, and you'll be able to look at them. So here it is, Desmos.com. And again, it's a super easy website to use. I've typed in my equations here, and you'll notice the calculator comes up on the bottom. There was my first one, and here was my second. And if we're looking at it, my red graph actually has an axis of symmetry right along x is equal to 5. Now, with that being said, we don't want that to be the axis of symmetry. We want it to be x is equal to 3. And judging, let me see if I can zoom this a little bit bigger. There we go. If we look 3 spaces over, or rather for that vertical line of x equals 3, my blue graph, negative 4x squared plus 24x plus 21, does fall directly on that line, x is equal to 3. And therefore, that maximum is on my vertical line of x equals 3. And that is the actual answer. Now, it's super helpful to graph this. And if you don't have a graphing calculator, I highly recommend that you use this website. All right, it's a really easy tool to use, and it's very helpful. So going back to our page, we see that our choice should be choice 2. And question 4 is going to ask you to do almost the exact same thing. But in this case, we actually are looking for a minimum value. Now, my minimum value occurs on that line, x is equal to negative 7. And being that it gave me a value, I know my minimum will occur at the point 7.5. Now, for this one, you could use a calculator. Or you can more simply substitute in an x and a y value into your quadratics and see which one actually makes a true equation. All right. Now, hint, hint, I know that choice 2 and choice 4 have that negative a value, meaning it will have maximums. I don't want maximums, I want minimums in this case, leaving choice 1 or 3 to be the answers. I will let you guys figure that one out. Now, question 5 says the parabola y equals negative x squared plus 12x minus 11 has an axis of symmetry at x equals 6. Now, that tells me, well, 1, I have a maximum because my a value is a negative. It's negative x squared, or negative 1x squared. And 2, that axis of symmetry falls somewhere along that vertical line of x equals 6. So I should have a graph that looks something like that. Now it says, which of the following represents its range? Well, if I know what my x value is for my maximum, I can substitute that into the equation and actually find out what my y value is, and which that would be my largest y value of the graph because it occurs at the maximum. So now, let's take our graph, our equation, and we're going to substitute in 6 for x. And you'll see this works out very nicely, because we have positive 36. Oh, excuse me. I'm sorry. Put parentheses around that. And 6 squared is 36. So then apply your negative sign to give me negative 36. Plus 12 times 6 is 72. Minus 11. Negative 36 plus 72 is 36. Minus 11 equals 25. Now that means that my maximum occurs at that point 625. And that I will have all y values that are strictly less than 25. What's my answer? Well, it's pretty obvious in this case. Choice 2. My range is represented by the inequality y is less than or equal to 25. All the values on my y-axis will be 25 or lower. All right? That's it. That's a little bit of algebra mixed in with quadratics. Again, that graphing calculator on desmos.com, DESMOS.com, is super helpful. I highly recommend it. And I hope you guys were able to get something from this video. Have a wonderful day.